Moving on with the program, advances in visual technology have been amazing. We've all seen it with television. I know we just got a new TV after we moved here, and it almost freaks me out. It feels like you're in the room with the actors, and it's kind of weird, but it's really awesome. The images are very sharp and crisp and lifelike. And that also extends to large displays such as video scoreboards, LED displays, and message signs. And here to talk about the technology behind that is Nate Nearman from Daktronics. Nate, please come on up.
I just want to see the light.
All right, so figure out my remote here a little bit quick, but we're going to start with a little housekeeping. Those of you who are observant will notice that I am not this guy. He's much better looking, and it turns out that Adam had something pretty urgent come up and high priority over the weekend. Him and his wife had their second child. So that means, you guys are kind of stuck with me for a stand-in a little bit. I'm Nate Nearman. I'm with Daktronics. I work with Adam closely pretty much every day. And I'm a part-time Adam Gillian stunt double. I was practicing with the chainsaws real quick when this came up. I didn't get them quite where I wanted to be comfortable to be safe for everybody. Ironically enough, much like this presentation. So I'm going to ask for a little understanding. I might not be as polished here as I would like to be, but please bear with me. Daktronics. Sports and scoreboards, you're probably very likely familiar with your favorite professional sports team, or you've seen us there. A college, even your local high school leverages our products. But that's not the only place. You probably see our product on your drive to and from work. You might see us outside your local retail center or a gas station. Maybe when you drop your kids off the pool, you'll see us. Maybe you visit London or New York or Las Vegas on vacation or for business. You'll see us there. We have these iconic type of locations as well where our product is. Sometimes in the movies we make it in a backdrop in Times Square or Piccadilly Circus like this. All these displays we looked at leverage this common technology of light emitting diode, or LED. Now, LED has been around since the late 60s, early 70s in commercial applications for green, red, and amber. However, it wasn't until the blue LED had enough intensity and enough intensity reliability over lifetime in the mid-90s that it became viable as a video application. And that means that you can put a red, a green, and a blue LED together and form a pixel. With those three colors, you can leverage millions and trillions of colors by changing the intensities of those things. That's where it became viable for Daktronics. And I'm here today to share with you over here our screen. I think Cheryl talked about it a little bit in her intro. This is one of our new products. We call this our narrow pixel pitch, or NPP product. And it's very popular. You can see the bright, vibrant colors, the deep contrast you get. And it's interesting, you can compare like the intensity that you might see there and the colors versus some projection or these LCD screens behind me. I think Cheryl also mentioned it, how popular you might be in your neighborhood if you had that screen and had people over to watch the game on Saturday or Sunday too. So what is narrow pixel pitch? We define narrow pixel pitch as direct view LED display less than about 2.5 millimeter in pitch, which is maybe about 1/10 of an inch for folks that aren't maybe as familiar with the metric system. And then what is a pixel pitch? Pixel pitch is the center-to-center distance between each RGB pixel. I'd invite you maybe a little bit later to walk up to the screen, kind of get a close-in look, and you can see how far or where that light is coming from, and that is this pixel pitch. Also, maybe to give you a little perspective, maybe a show of hands, who has a 55-inch LCD HD display at their house for their home viewing, right? So that, for a little perspective, is a 0.63 millimeter pixel pitch. So between the red, green, and blue in there, there's a 0.63. Anybody have a 65-inch LCD at home? Those are a 0.75 millimeter. And anybody maybe recently purchased a 4K 65-inch? Okay, we got a few folks here. That is a 0.375 millimeter center to center. And what happens there is you go from a UHD, which is a pixel count, to 4K, which is actually 4 times that pixel count. They're cramming more pixels into that same square area, and you get a more vibrant image because it has higher resolution. So in our Daktronics lineup, we have a 2.5, a 1.9, a 1.5, and a 1.2 millimeter pitch. This one we show today is a 1.9 millimeter. 1.9 millimeters is about the thickness of a nickel between each of the pixels in that display you see over here today. So we did a little education for you. We're going to continue with a little more LED display education. They come in all different sizes and shapes. What we show here is larger LEDs spaced further apart gives you less resolution. You might see this over the road. You go up and down I-29 or east and west on I-90 here in Sioux Falls, we have a display much like this. It's for motorists traveling at 80, 85, 90 miles an hour, and or maybe some faster. And you got a viewing distance that you have to consider there. On the other hand, we'll have smaller LEDs spaced closer together to get you higher resolution, like in this press backdrop here. I do have a few samples. Just to give you a little more perspective, this is a through-hole LED. This is the type of thing that you'll see in that over-the-road type of display, or even in the sports stadiums, or in like that Piccadilly Circus application. And then on the other side, we have what we call this surface mount LED. This will be much more difficult for folks to see that maybe aren't right in the front. This is that smaller LED we can place closer together to get those higher resolutions. The pixels that are in that display there are almost about the size, or about 1.5 times the size of a flake of pepper. Right. I could show that, and you wouldn't know it anyway from up here, right? And then what's all that mean? It's all about this resolution to a viewing audience's distance and how far someone wants to be from it. We call a viewing distance where that pixelation kind of goes away. I like to think of it as a screen door effect. If you walk up to this display over here within maybe 3-4 feet, you can kind of feel like you're looking through a bit of a screen door at that image. You can see the X and the Y horizontals of a black until it begins to blend up. And then you step maybe one pace back, and all that goes away and it's blended together. You'll see that too if you ever research and look for your own home audio. They have recommendations of how far your viewing should be for like a 55-inch or 65-inch LCD. We'll go through a little bit of screen evolution here, maybe paint a little context for you. There's this thirst for visible image reproduction, and it's been evolving. Cheryl talked about it when she moved and got a new TV. It's like how lifelike it is. There's this movement towards lifelike. However, it maybe started back when CRT became available, and people were like, oh my gosh, it's got an image, that's great. I don't know if you remember maybe 80s and 90s, we probably all had a 25-inch or a 34-inch CRT TV. That 34-inch might have weighed about as much as I do, but man, you could watch the game on it and it seemed big and great. Later here in the maybe late 90s, early 2000s, the LCD and higher resolution things became more available. So people started talking about 720p and all these things, 1080 type of stuff, these UHD screens. Pretty much everybody has those in their home now. We have them here, things like that. And then today, we're getting more and more towards this more highly realistic, and that is this journey that we're on to making screens show very lifelike images. I think too, we see it today in our phones. It's kind of interesting, we see this happen in all of our devices, our phones, our watches type of stuff. Screens have been getting continuously better and higher lifelike images. So here we have like an iPhone 6, had about 163 pixels per inch. Here's an iPhone X or XS, has about 458 pixels per inch. That's 3 times the pixels in it. And if I don't know if you're much like me, I don't get every release of a phone. Maybe I skip one, but when you're standing there and you're getting your new phone and you're kind of setting up your new phone, you're looking at your old phone, you're like, man, look how bright that is, or look how vivid the colors are when you're looking at pictures on one phone or the other. And it's because this newer phone has so many more pixels in it. And with those pixels, you get this higher definition that you can paint on a picture. We see this today too. Basically, the trend is packing more pixels into a given area to get you your resolutions. 55-inch, 65-inch, 70-inch LCDs fit in many home living room, or residential areas. So people are packing pixels into those to get to these higher resolutions of 4K and 8K that is coming as well. Now, what's that all mean for Daktronics and me in my world? Big displays are having the same thing. We're riding that same wave towards more lifelike images. Here you see a couple examples. The one on the left is a shopping mall, high-end shopping mall, where we're putting this higher resolution displays. And on the right is maybe a corporate lobby. And in these instances, people want this lifelike, realistic look because it portrays them positively as their brand. Also in a shopping mall, they'll put fashion things up on them and have people want to come in and buy that clothing line or whatever because it looks very nice, it looks lifelike. Here's a application for concourses, especially well-lit ones because of the intensity difference. There we go. And then backdrops on maybe sport concourses or sport clubs. This is over a bar in Mercedes-Benz Stadium. High resolution display, very close, and that's where it's close viewing public. And then press backdrops. They look very good. You can watch a lot of pressers, or they'll have a little clip of a presser in like Sports Center or something, and a lot of folks are in front of these LED displays in the background. They look really good on camera. You don't get a moire effect. And then also you have this vividness. I could tell you Mercedes probably pays a little bit more to have their emblem behind Matt Ryan there than if it was a vinyl or a LCD. LCD, by the way, is one of our competing technologies that we see. Here we did a shootout. We brought an LED display to a customer that had a LCD video wall and talked through with them the benefits of LED versus LCD technology in their application. You can see the bezels, you can see the lines there and the vividness, the intensity. We made a sale of 4 displays off of that. So maybe some LED benefits, high brightness, this high contrast, that's what makes that picture kind of pop for you. Also, the reflectivity is a big deal there versus competing technologies. Bold colors, flexibility in application is a big deal. Each one of these panels that we create here is about 13 and a half inches tall by 24 wide, and you can build those up as building blocks into whatever size you would like. LED versus LCD comparison here. Longer lifetime, this modular design and flexibility, and that better contrast. And then here's a side-by-side in that presser backdrop. On the left, we have some folks with a LED display in the back, and on the right, we have an LCD. And you can kind of see that contrast, that reflectivity differences that you'll see there. I don't know, too. Anybody have their home LCD, and they kind of wish that you could watch it with the lights on or watch it with the windows open. That's that kind of high ambient opportunity for our LED product. And then here's maybe a LCD in a large video wall application in a high ambient. You see the mullions kind of separating things out, kind of draws from the image. Also, LCD maybe doesn't age as well as LED. So we're going to step through a few applications of where this product, where this technology can be applied. Control rooms. Ed mentioned one. He showed a control room. This is control rooms for military applications, broadcast control rooms, simulations. Folks want to be close to the display. They want that lifelike thing, but then maybe they want the entire display to have this moment to where you can project, or you want to zone it out and make these little things. You're not driven like that by LCD. Corporate signage is what we call this area. Maybe a ESPN backdrop. You can see I'm talking over a screen. The United Nations in Europe, their headquarters, they have a big LED display as a backdrop for presentations. Also, corporate signage we shared. Here's Tottenham Hotspurs, a recent install we just did, English Premier League, a press backdrop that they have this giant LED screen behind them, and they'll run plays or replays and stuff on it and have a backdrop for their presser. Hospitality, casinos, hospitals, hotels, kind of an interesting space. Huge opportunities in sports books. I don't know, folks have ever frequented a sports book. I know I've heard about them myself. I've never visited one. But you know, they have all these displays up, and they're often a combination. There's some LED in there, there's LCD, and sometimes there's even projection that they're showing up there. We could put that all in LED. They could have the Super Bowl on all one screen there, or whatever they would like to do. Another interesting one, esports. It's getting to be a bigger deal. It's always interesting. I've been to quite a few trade shows for Daktronics and worked in the booth. It almost never fails that someone comes up and goes, man, that's a cool screen. I'd love to plug my Xbox or PlayStation into that. You're like, yeah, that'd be cool. Well, now people are getting paid to do that. This is a great application here because of that vividness. The refresh rate is pretty good too. We also categorize arenas and sports stadiums indoor in here. Denny Sanford has Daktronics product in it. And even houses of worship. Interesting, you know, those little side monitors for folks to follow along with. Retail, there's some big opportunities in retail for us. This is an install we recently did out in California for Skechers. Of note here too, towards that flexibility, if you look, these are two displays coming together and making a corner, and that corner looks pretty seamless. You know, you don't have a 3-4 inch gap between anything there. And then any Twins fans here? Okay, there. It took you guys a little while to raise your hand. You got to be, you know, I know the season's almost over, but next year's always coming. But anybody visit the Bat and Barrel when they have been there to Target Field? Okay, nobody. Wow, well, that's not fair. That really didn't set up my next question very well. So anyway, the Bat and Barrel here, this is it's on their second floor of Target Field. And then as we're looking at this, off the right side is the stadium, and you're down the right field line. Whole bunch of windows all around this thing. And then our 2.5 millimeter product is kind of wrapped around that bar area there. It's interesting. I've been to this, got to witness this. There's people sitting at these tables that are along the windows, and nobody's looking out the windows and watching the game. They're all turned inward watching the game on the TVs up over it, so it's kind of interesting. But there's great applications there. So about that high ambient area, and then some of those things that we can do with our LED product where you don't have to be driven just by 55 inch or 83 inch or 65 inch LCD sizes. Buffalo Wild Wings is someone we're working with. If you've ever been to Buffalo Wild Wings, you know, they have LCDs hanging everywhere with all kinds of games and things going on them. If they could put LED product in, it would open up some of their architects a little bit for some ambient lighting. They could do some more interesting things with their space, but also this moment of exclusivity. Imagine going to Buffalo Wild Wings and being able to watch the Super Bowl or the Sunday night game all on that one screen. But earlier in the day, they had it divided out into the whatever 10 other games that were going on. Transportation is another area that's kind of intriguing. We are working with some international airports to create displays like you'll see here at a baggage claim area or in a concourse. High ambient light, again, it's about letting architects have some kind of interesting freedoms. So finally we get to a graph. I'm an engineer. It took me a long time to have to wait to get to here, but this is a market maturity graph. You know, and as the technology becomes more stable, it raises up the graph, and then you get into some maturity periods. Maybe 4 years ago or so, LED industry as a whole was reaching up towards the top in this red star, and that's not a happy place to be. With some of these advancements that we're having and some new technologies, we're maybe back down here in the happy place around this fast growth area for a lot of the applications that I just went through. There's many opportunities. Sharing our technology with people can help them understand where these things can fit and work. We'll look a little bit at some of these emerging technologies and what's helped us reset that graph a little bit. This is that through-hole technology. This is stuff that it's known technology, known processes, known equipment, hundreds and hundreds of places can produce these parts today and do it cheaply. This surface mount technology, less than hundreds can maybe do it, but it's still something that can be pretty easily commoditized. We can struggle with our Asian competitors here. But, so what's next? Chip on board, chip on substrate, chip embedding. These are the technologies that we could use to be more efficient, more cost effective, and have higher performance qualities in this less than 2.5 millimeter space. Those are things that we're working on today. So, as we look into the future here, these new disruptive technologies are on the horizon. There's no clear winner in any of those yet. These things are, we're working to figure out some of those and which ones work where and don't work so well. Wave innovation is going to continue as we keep going. Mini or micro LED, those are some buzzwords you might hear. I don't know if you watched the Apple keynote or anything, but there was always some discussion in those about mini and micro LED uses in phones or on watches. Those are things that we're actually looking at. I have a few samples if you want to stop by, and I could show you those a little bit later. And then, you know, we have a bright opportunity in this narrow pixel pitch into the future. Yesterday I was asked a little bit to think about what Daktronics does to try to be innovative. It's maybe a little more interesting topic, had to put a little thought to that. It's not something that is just one thing that I could point to, I think. I think there's multiple ways to try to be innovative, and it's no set process. I think that's what makes it very difficult. I think a lot of it starts with listening to customers, looking for market trends, getting out and getting to talk to people that are trying to solve problems in their business or in their world, and then how you can help them, and then look for some of those trends that you might see. And they might be trends that you get from a customer, but it might be technology trends you see from competitors, it might be technology trends from folks in adjacent markets, and it might even be things you're learning from your own supply chain. I also believe that simple problem-solving methodology at all levels is a huge key to innovation. At Daktronics, we try our best to follow Plan, Do, Check, Act, PDCA. And in there, we aren't afraid to experiment. You got to experiment and you got to learn and embrace failure. That's a hard thing for all of us to do, and also to teach it to others and to reinforce it in others, because we don't like to fail. And make problems visible. Write it down, put it on a whiteboard, and start scratching things around with other folks. Problems are just words floating around in the air until you can get them down on paper and work on them with someone else. Relationships are a huge key. I think with your vendors and tech partners especially, your tech partner person might have a quarter of the solution and you might have a quarter of the solution. And if you can get together, maybe together you can figure out that other half. Or you can find where there's strengths and weaknesses and you might overlap pretty well with a technical partner. And then I'm a big believer in our process, our people, and our tools. At Daktronics, we try to follow scaled agile framework. It's an agile development methodology. Is anybody familiar with that somewhat? So it's generally thought to be highly software. And anything you go out and read is people writing code every day. At Daktronics, we're attempting, and we have been implementing for the past probably 3 to 4 years, using agile methodologies throughout our development organization. And that's from the guys that write code, but also to the guys like me that are mechanical engineering-based folks. We're applying the sprint methodology, we're doing planning events, we're doing scrums, we're doing all those kind of things, all up and down the line of our development areas. Huge process improvements that we get there. Also, when you have people that are maybe more focused on or when you have the processes in place, it frees up people's minds a little bit to be a little bit more innovative. Additionally, we've been studying the heck out of lean product development. It's kind of interesting. I see some folks in the medical industry. I've attended a few of these lean product development things, and they're applying this at hospitals a bunch, making problems visual and using PDCA type of stuff there. So there's some interesting things that can be done with those processes. And that's all I had. Any questions?
Chris Nelson, Public Utilities Commission. You talked about trends. Help me understand the energy consumption trends as we move from LCDs through the various versions of LEDs. Can you speak to that at all?
That's a great question. So, LED is more efficient than LCD because LED is an emissive technology. LED, you have backlights and it goes through a plane, so you lose maybe 50 to 60% of your output light from the back plane to the front plane. For example, we are developing a new product that would be a semi-outdoor application that would use, I think it's 1/8 the amount of energy to create twice the intensity of an outdoor LCD in that application. So they're more efficient, and they are getting, there's a top-end curve to that where they'll reach, but they're maybe 3 to 4 times more efficient than LCD in general.
Hi, Justin Lunsky with Avera Health. I was just curious, I know in the residential area the OLED technology is starting to become popular. Is that something that you guys are going to be incorporating as well?
That's a good question. Organic LED is something we've looked at a little bit. It doesn't have the intensities that we often need to get to where we need to get. Also, there's some limitations in how big you can use them. Like in a watch or in a phone size screen, you can use those, but if you're outdoors ever, you know, and you always get that problem with your watch or your phone screen, those are some problems with organic LED. They kind of rode the wave a little bit maybe 4 or 5 years ago, and now we're starting to see that organic LED go down in favor of some more solid state LED. All right, thank you.